Good morning. This is Unit 2, Day 4 notes. Today we're going to go over how to graph our trigonometric functions. So I'm going to go over sine. In order to do sine, I'm going to look at the unit circle. And remember, at this point right here, this is when our x value is 1 and our y value is 0. This point right here is when our x is 0 and our y is 1. At pi, my x is -1 and my y is 0. And at 3 pi over 2, my x is 0 and my y is -1. Okay. And then I'm going to remind you that sine is your y values. So all I care about going around the unit circle are my y values. At the radians, I'm going to look at when our radians are 0, pi over 2, which is 90 degrees, pi, 3 pi over 2, and all the way back here to 2 pi. So remember, sine is your y values. So at 0, sine's value is 0. At pi over 2, sine's value is 1. At pi, sine's value goes back to 0. At 3 pi over 2, sine's value is -1. And then at 2 pi, sine's value goes back to 0. Now I'm going to space these out on the coordinate grid a little bit. If this is 0, this one I'm going to say is pi over 2. You can put it right here. You can put it right here if you would like. I'm going to put it right here just to spread it out a little bit. And then right here, this right here is pi. This is 3 pi over 2 and 2 pi. I'm also going to show you what happens on the other side of the y-axis. This is going to be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. I don't think I skipped anything. All right. Now, at 0, my sine's value is 0. But at pi over 2, my sine's value is 1. Let's say 1 is right here. And then that means -1 is right here. At pi, my sine's value goes back to 0. At 3 pi over 2, it is at -1. And then at 2 pi, it goes back to 0. So sine's graph looks like this. Oops. And it's going to keep on going forever. It's just going to repeat. Keep on going forever. And then also this side, it's going to be symmetric. So it started up, it's at 0. It's going to go to -1, 0, up, 0. So it'll look like this. We're just repeating it. The domain of our trig functions, at least sine and cosine, our domain is going to be all real numbers. Capital R is all real numbers. My range are my y values. My y values go in between 1 all the way to -1. And they do include -1 and 1. Sorry guys, there was an announcement. So my range is going to be between 1 and -1. -1 and 1, and they do include 1 and -1. So we're going to use the brackets. We always put our smallest number first and then our bigger number. My equation of a midline, this is going to be important when we start shifting our functions. The equation of the midline is going to be the line. It's going to be kind of like an axis of symmetry, but the line that kind of cuts our trig function in half. And in this case, it's going to be y equals 0. So the equation of the midline is y equals 0 in this case, and the amplitude in this case is going to be 1. If there's no number in front of our trig function, there's an imaginary 1 there. So in this case, my amplitude is 1, and this is going to be the distance between the midline to the max. the distance between the midline to the maximum is 1 unit. Also, the distance between the midline to the minimum is also 1. My period means that this sine graph is going to make one full revolution between 0 and 2 pi. That distance is 2 pi. The x-intercept is going to be, where is my graph hitting the x-axis? Well, it hits the x-axis right here at 0, right here at pi, right here at 2 pi. So every interval of pi. So we're going to say k, which is just a number, times pi, could be 0. And this is every version of k. So as long as k is an element of an integer. This z means integer. All right. Go ahead and go down. Let's look at what the cosine values are. I'm going to use the same radians. So 0, pi over 2, pi, 3 pi over 2. Oops. Sorry. We just reread it. I'm sorry. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, cosine is our x values. So right here, our x values are 1. So when our radians are 0, our x values are 1. At pi over 2, my x value is 0, and then negative 1. At 3 pi over 2, my x value is back at 0. And then at 2 pi, my x value is again positive 1. And I'm just going to plot this in the graph. This is pi over 2, pi, 3 pi over 2, and 2 pi. Again, negative. This is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, so at 0 radians, my y value is 1. So instead of starting at 0, we're going to start at 1, right here. And then at pi over 2, my y value is 0. And then we go to negative 1, and then 0, and then back to positive 1. So my tangent, my cosine graph looks like this. And it's going to be symmetric on the other side. Keeps going. Negative 1, 0, 1. So it's going to just keep oscillating back and forth. Keep going back and forth. So the domain, just like sine, the domain of cosine is all real numbers. My range is still going to oscillate between negative 1 and 1. That's why this one looks weird. So also between negative 1 and 1. The equation of a midline, at least for this function, is still going to be y equals 0 along the x-axis. The amplitude, if there's a number in front of your cosine, that's going to be your amplitude. If there's no number, this one is 1. Your period, cosine still makes one full revolution between 0 and 2 pi. So that distance is 2 pi. The x-intercept is going to be pretty much the same. This one is every interval of pi over 2. So we're going to say every interval of pi over 2 will look like this. So let's go on to tangent. Tangent is going to be a little bit different, and I'm going to explain why. Remember, tangent is sine over cosine. And at these points, you know that this point is at 1, 0. This point is at 0, 1. This point is at negative 1, 0. And this point is at 0, negative 1. So at this point, my sine is 0 over cosine is 1. 0 over 1 is all right. But when we have 1 over 0, that's not okay. 1 over 0, you cannot divide by 0. That's undefined. So that's going to be an asymptote. We're going to have an asymptote there. What I'm going to do is just look at the numbers in between my asymptotes. So let's look at negative pi over 2. Let's look at negative pi over 4. Kind of I get an idea of what tangent looks like. 0. Let's just be symmetric. So we'll do pi over 4 and pi over 2. So at negative pi over 2, that means we're going to go clockwise instead of counterclockwise. Pi over 2 is 90 degrees. So at this point right here, we're 0, negative 1. And it's sine over cosine. So negative 1 comes first. We're at negative 1 over 0, which is undefined. So at negative pi over 2, there is going to be an asymptote there. Actually, I have a line I can use. Okay, now let's do pi over 4. Pi over 4, my reference angle is 45 degrees, so I need to know my 45-degree triangle. And my ratios are 1, 1, square root of 2. Tangent at 45 degrees is opposite over adjacent. And that's 1 over 1. And in negative pi over 4, that's right here. Negative pi over 4 is right here. Tangent is negative there. Only cosine is positive. So this is negative 1. So it's going to be at pi over 4 down here at negative 1. At 0, tangent is sine over cosine. So 0 over 1 is 0. And then at pi over 4, that is 45 degrees, 1 over 1, which is 1. Pi over 4, just regular pi over 4, is in the first quadrant, which means tangent is positive. And then pi over 2 is sine over cosine, 1 over 0, and that is also undefined. So this is maybe pi over 4, and then at pi over 2, we again have an asymptote. You can try other points in here to see kind of what tangent looks like. You can try, especially your special right triangle, like the 30-60, but tangent is going to look like this. Okay, and it's going to repeat. One, two, so 4. Alrighty, and tangent is going to look exactly the same. It's just going to keep repeating. It goes through these 3 points. And it's going to keep going. These 3 points. So tangent's a little bit different than sine and cosine. Something like that. Okay, the domain is different. There are holes in my domain now. So a tangent is going to be, x is all real numbers, except x cannot be any version of pi over 2. So right here, this is negative pi over 2. This is pi over 2. This is going to be 2 pi over 2, 3 pi over 2 right here. So we're going to say k pi plus pi over 2. as long as k is an integer. So I'm going to write that properly, actually. So comma k has to be a whole number. This z means integer. Whole number can be positive or negative. The range, tangent is different on that. The y values, tangent goes all the way up infinitely forever. It goes all the way down infinitely forever, and there's no holes in between. So my range in this one is all real numbers. Y is an element of all real numbers. Capital R with like an extra little line. Our period for tangent is different than sine and cosine. It goes between negative pi over 2 and pi over 2. If we add them up, what is pi over 2 and pi over 2? That is pi instead of 2 pi. My x-intercepts are going to be whenever right here. So right here, it hits the x-axis at 0, at, if this is pi over 2, 2 pi over 2, which is pi, it hits the x-axis. So we're going to say k pi, multiples of pi, every multiple of pi, as long as k is an integer. That'll give you multiples of pi. That's where it hits x-axis. There are asymptotes in this, and that's when we have our restriction in our domain. So these are my asymptotes. Whenever x equals k pi plus pi over 2, as long as k is an integer. Okay, a periodic function is a function. A function is called periodic if there's a positive number such that whatever for all theta in the domain of f, so is theta plus p. Okay, it's just going to repeat. Sine repeats. So we talked about sine already. Sine starts at 0, and then we said the period is 2 pi. Because after 2 pi, do you guys see that it just keeps going? It's the same thing over again. Do you see that the blue curve and the red curve are going to be the same? Also, the purple curve is going to be the same. It starts at 0, goes up, 0, -1, 0. That's the same as the blue one. So sine is periodic. Sine at 17 pi over 4. I know 8 pi over 4 is 2 pi, so I just need to subtract multiples of 2 pi, or go around my unit circle until I can get my reference angle. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8. If I go around again, that's 16. So 17 pi over 4 minus 16 pi over 4 just gives me pi over 4. Okay, so if I go around again, this is going to be my reference angle. So what is sine at pi over 4? We know that this is my 45-degree triangle, and my ratio for my 45, 45, 90 is 1, 1, square root of 2. And sine is opposite, which is 1, over a hypotenuse, which is the square root of 2. We always rationalize our denominator, which means we're going to multiply the top and the bottom by the square root of 2. And then we're going to get square root of 2 over square root of 4, which is 2. Okay. These are just a couple of identities. We're going to go over more in this, the second chapter of trig. This is cotangent is 1 over tangent. Cosecant is 1 over sine, and secant is 1 over cosine. I know we've went over this. Now the quotient identities, tangent is sine over cosine. You guys know this. Cotangent is the reciprocal. So it's going to be cosine over sine. There's this really cool Pythagorean identity. You guys know the Pythagorean theorem? And we said if this is my x value, my x-axis, and this is my y-axis, and we know this is a unit circle, which means my radius is 1. We know that the Pythagorean theorem is x squared plus y squared equals my hypotenuse squared. 1 is always going to be my hypotenuse. But you guys know also that on the unit circle, cosine is my x's and sine are your y's. So I can use this information to show you that x squared, well, cosine are my x's, so cosine squared plus y squared, well, sine are my y's, so sine squared equals 1 squared, which is 1. And this identity we're going to use a lot, and we can manipulate it to give us other identities, but they all come from this. So if we have this, which is cosine squared plus sine squared theta equals 1, I can divide by things like, let's divide by sine. Oops. If you divide by sine, everything has to be divided by sine. Cosine over sine is cotangent. Sine over sine is 1. 1 over sine is cosecant. Still squared. They're all squared. Alrighty. If we started with this one, our original one, and divided by cosine instead of sine. Say we divided by cosine. Then cosine over cosine is 1. Sine over cosine is tangent. 1 over cosine is secant. And those are our identities. Just a couple. We'll learn a lot more. I want you guys to try these 2 examples. Try them out and let me know if you guys have any questions.